Okay, I will. I think we have had a very large number of presentations that dealt with ontologies. I will give a slightly different perspective, or a perspective that is complementary to what you have heard. In many of the systems that we deal today, we span the entire gamut of things that are physical in nature, things that are in the cyber environment, and the things that involve people and social activities. So there is this emergence of physical cyber social systems, and that just the same way that ontologies or semantic models make it easier for you to integrate data at one level of representation. Say you integrate relational database, you integrate RDF databases and such. The real world phenomena that this community deals with are fairly complex, and that you need to be able to deal with the data that spans the observations that occur on the ground, all the way to some decisions that are made by human that may involve coordination, collaboration, and interactions, and so on and so forth. And in between all that, cyber environment plays a very big role. You have this ontology that resides on cyber environment, right? You have this RDF data that resides on cyber. You have this model of a sensor, your model of a weather phenomena that resides on cyber environment. And so thinking about along these dimensions, another interesting way to think about a holistic way of solutions, coming up to the solution to what we are talking about here. One way to look at the challenges that this community itself is facing and will face is to look at what has happened on the web. So we started the web with web of pages, and then we had web of databases. People started to put dynamic database, web pages. And then we started to get web of resources. We had web services and mashups and all the things of that nature. We also got all these mobile computers online. 4 billion, there are more than 5 billion connections now, and well over billion are data connected. We have more than 40 billion mobile sensors out there, and we have people that act as sensors and the physical sensors that are there. And then, and so the complexities are kind of moving on. And as we see this move, I also see the role of semantics moving. And we also are not limited to a very traditional notion of semantics, as in building an ontology in OWL. The semantics can be, there is a paper that I wrote a while ago, Semantics, the Formal, the informal, and the powerful. So just the same way that you may use statistics to capture something, and that in a way you can name it, and that can be a semantic thing, as much as you may have a logic-based representation for semantics. That whole thing. And corresponding to all these things, we also increasing the depth of understanding and analysis of the data. We started with keyword, and search engines still heavily use keywords, but then we are increasingly paying attention to patterns, understand the objects by using Freebase and other things. So-called semantic Google is trying to, has an understanding that that is a person that you search for. And some of us, built products a decade ago, but now this is coming out at web level. And then you're going into events and situations. So you're getting a sense of an event that is occurring, and getting a sense of all that. In all this, then the role of semantics actually is increasing. Correspondingly, the depth of solutions that you will get in geosciences, again, the semantics will play a very critical role in getting important solutions, deeper solutions. Now, what we have to realize is that there is a very vast ecosystem of data, information, knowledge that you'll have to deal with. At one level, you'll have to deal with all kinds of data, and then you'll deal with variety of things at the metadata and the use of data, you search, browsing, integration. And as you go from search to browsing to integration to analysis, your need for semantics and the depth and quality of semantics, semantic representation will change, and you need to be able to support all of them as you go along. And then you need to be able to help people make decisions and get a situation awareness. On the side, I just mentioned a couple of infrastructure efforts. One of the earlier talk did mention sensor web enablement, OGC sensor web enablement. We had W3C had a semantic sensor networking a group where we defined sensor ontology and the techniques for annotating the sensor data. And there is also this widely adapted concept introduced in 2008, semantic sensor web. You just Google for it, you'll see. And increasing amount of sophistication is being added by putting semantics to the sensor data. Now that is going to also social data. And that is, of course, applicable to the web data and so on and so forth. Very briefly, if you're not aware of NOESIS, the Ohio Center of Excellence in Knowledge Enable Computing, about 50 PhD students. What is very important is that we do highly interdisciplinary work. So we have a good bit of project with health and bioinformatics, or biomedical and social science and all that. And the semantics, in our case, we have projects where semantics play role in all of this. We do semantic web services and cloud interoperability using semantics and a whole variety of different things. So, but one at a very broad level, here is an architecture that has worked very well for us. Essentially, you have to deal with a broad variety of data, right? So it is very unusual these days that any significant problem solving involves just one type of data. You're going to have images, you're going to have sensor data, you're going to have textual data, and so on and so forth. So semantics is the equalizer in a way. You want to abstract away from the heterogeneity at the data level. That means that is where the semantics comes in. We start supporting semantics typically by having semantic models. In fact, I have deliberately not used the word ontology. There will be a lot of solutions that this community will find that will have some semantic support, but would not necessarily use ontology, formal ontology in OWL. That there will be plenty of other alternatives that may be also adequate and should be supported. So you start with a model that represents some form of agreement, right? And then with that, you annotate the data. By having the metadata, now you have abstracted away from the data level heterogeneity. And then on that annotated metadata, in RDF typically and such, where relationship is a first class object, which gives you the significant power, you can develop powerful solution that goes from search, integration, analysis, discovery, and so on and so forth. Question answering, that is increasingly happening. Okay. Now, ontologies can be very simple, can be very complex. Like in this ontology, we are capturing the process of a biochemical process that occurs of this particular chemical reaction. So ontology can be incredibly complex, can capture a lot of detail. Should you do that? It all depends. I won't go into any of those details, but get a sense. Once you have the ontologies, you can do annotations of all kinds of data. So here is an annotation of textual data, and here is an annotation of sensor data. So you have data here that says, and by the way, in this case, you have spatio, temporal, thematic ontologies. And then so you can see here live sensor data stream coming in, you are annotating all of that. You are then doing a semantic abstraction of perceptions because you are interested in weather phenomena, for example. You're not interested in data, you're interested in whether there is a icy road condition. And then we publish that as a linked open linked sensor data, I believe, cloud and that kind of thing. Let me show you now extremely quickly a few real functioning applications and systems. So this is an application that gets data from 20,000 MesoWest sensors, weather. And the idea here is that somebody is interested in what kind of weather there is, in this case, in a particular area. So here you are doing searching, deciding the day or time, location, and there you are selecting particular weather phenomena and say, does the data support this particular weather phenomena? So here, this particular thing would show you if there was a blizzard or certain icy road condition or things of that nature. So you can see that there are a couple of dots came up, and there it'll show you supporting data that shows blizzard, right? So this kind of thing can be done. All this is on the fairly significant live sensor data. Or this one is, and these are all available as web service. So this one is showing you a variety of conditions here in, I think, Utah, blizzard, flurry, rain showers and so on and so forth. Okay. Then here, this one shows you, for example, a live real-time processing of the sensor data and showing you what kind of weather condition there is. That one was not live. Here you are able to see, ask on the Japanese tsunami, and here you can say what happens during Japanese tsunami, and let's see if I can find a prefecture. Here somebody is asking, telling the US, let's see, Ambassador Roos, communicate with Ambassador Roos during the Japanese earthquake, and you can do that live right now as we speak. This is for the election, and you can see discussion was on student loan yesterday, and you can see the real-time analysis of all the sensor data coming in, kind of. I'll wrap up. You can see sentiments and network and many of the things you can do, but basically this is human-generated sensing data. And here is a set of sensor where you are getting raw sensor data, but then you are showing you the type of fires that are identified. So something that is meaningful to the user. So now that my time is running out, I'll show you one last thing and get out of the way. Recently I gave a talk, and the talk was about at the community, the spatial ontology community workshop. And we just did this query: what schools in Ohio should now be closed due to inclement weather? And the interesting thing was that as you look at this, which involved 5 subsets, and within them each of very complex set of queries to be answered. The interesting thing here is that when you answer to just do that single query, there is so much role of so many complexities, and it will be very hard to do these kind of things without significant role of semantics. Now we are building systems that are supporting spatial temporal thematic and social and sensor data and a whole bunch of ontologies, and doing that kind of in real time, let's say for traffic and many other things.